Alright, in this video I'm going to be showing you how to find the zeros of this function. So first of all, normally to find the zeros we would set this polynomial equal to 0, but if you do that you find that you can't factor it. In fact, you have 4 terms here, so you'd try factoring by grouping, but that doesn't work. And so this is where we're going to have to use synthetic division. Now the first thing you should know is how to find the possible rational zeros. So you do what I call the P's and Q's. We're basically using the rational zeros theorem, which says any rational zeros will be of the form P over Q, where P are factors of the constant term here, and Q are factors of the leading coefficient, which is -1 here. And so our factors of P would be plus or minus 1, 2, 3, 4, 6, and 12. Those are all my factors of 12. The factors of 1 or -1 are of course plus or minus 1. And so we would normally write this way, plus or minus 1, 2, 3, 4, 6, and 12. So now when I went to school, the way we did this at this point is we would literally try each of these numbers and use synthetic division until we got one that had a remainder of 0, which would tell us that the number was a 0. Now I'm allowing you to use your calculator to get your first 0. So but just keep in mind, on the test you should at least be able to find the possible rational zeros. But when we're trying to actually do this problem, we're going to use our calculator to help us out here. So I put in the function, and then if you hit zoom, and you can do zoom decimal or maybe zoom standard, those are nice screens. I usually use zoom decimal. If you get the graph in the picture, it's probably the nicest screen. And so it looks like this. And you can see that it looks like you have a 0 at 1, 3, and -3. So in fact, it looks like we have all of them here. Now on a test, you can't just say, hey, I got my 3 zeros off my calculator. What I'm allowing you to do is take one of these zeros and use it, well, first of all, confirm that it's a 0, and then use it to find the other zeros. Now, a lot of times the other zeros are not going to be such nice numbers like they were here. So I'm going to use x equals 1. I usually try to use the smallest positive number. And so I would do this. I'd say x equals 1 is a 0. And I'm going to write calc in parentheses indicating that I got it off my calculator. And so now I need to show that it's a 0. And so I'm going to do synthetic division with this polynomial divided by x minus 1. So my coefficients will be -1, 2, 11, and -12. So we drop the -1, and then we'll multiply here. We get -1. In the columns we always add, so 2 and a -1 is 1. Then multiply, we get 1. Add, we get 12. Multiply, we get 12. And when we add, we get 0. And so that's not a surprise. That's what we were expecting, because we found that 0 on the calculator. Now, I mean, we could have made a mistake, but otherwise, if it's a 0 on the calculator, you should be confirming that here. But the nice thing is we can now write our function as, let's see, if 1 is a 0, we know that x minus 1 is a factor, and our other factor is coming from our answer here. Now, since we're dividing a cubic function by a linear function x minus 1, our degree is going to drop 1, and so this will be a -1x squared plus x plus 12. Now, I don't like having this first term be negative. It makes it much more challenging to factor these. So let's go ahead and factor out a -1. Which will cause all our signs to change. This will be x squared minus x minus 12. Now keep in mind, if you multiply -1 times what's here, you'll get back to where you started. So we're good. And now this factors quite easily using the AC method. And since this is a 1x squared, this is the easier type to factor. It'll be x times x gives us the x squared. And we need two numbers here that multiply to -12 and add to -1. So 3 and 4 are the ones that are going to work. And since they add to -1, you want the bigger one to be negative. And so when you factor this function, you get this factorization here. That means our zeros are 1, -3, and 4, all with a multiplicity of 1. Which is not surprising. This is a cubic function, and we have 3 zeros. Now keep in mind that this was a pretty easy problem. A lot of times what happens is we get down to this point, and we may have something that doesn't factor, but it's quadratic. So when we set it equal to 0, we can solve it using other techniques other than factoring. We can use quadratic formula or any of our other techniques. We could end up with imaginary zeros. We could end up with radical zeros. Anyway, so that's the approach that you would use to solve a problem like this and to find the zeros. That's it.